Hello everyone, I'm Paul and today we're solving problem 2327, number of people aware of a secret. This is a medium one with at least two different solutions, so next I will show you both. Let's say we have an array where each position represents one day. So on day one person discovers a secret. We will say the first value here is 1. And let's say n is 6. Meaning the size of this array is 6. Now this person can start sharing the secret after delay days. We are given this variable. Let's say for this example that delay is 2. And this person will forget the secret in exactly forget days. Let's say for this example that forget is 4. What this means here is this person can start sharing the secret here and will forget about the secret exactly here. So here one new person will find the secret and here another new person will find the secret. Here this person will forget the secret. So from this day we only have one person who knows the secret. This person can start sharing the secret here, so here we can put the 1 and here we have another 1. This person will forget about the secret on this day. Next we are at this day. This person can start sharing the secret here, so we can replace this with the 2 and will forget about the secret after 4 days. So here we have an array with the number of people who learns the secret at each day. And our job is down here. We need to return the number of people who know the secret at the end of day n, meaning at the end of this array. And what is the result here? Well, we can take the last forget people, the last 4 people in this case. Why? Well, because we know that each person can hold the secret for 4 days. So we take the last 4 days, we add these values, 2 plus 1 is 3, plus 1 is 4, plus 1 is 5, and we return 5 in this case. Now, in case you didn't notice, this looks a lot like a DP array. Why? Well, because we are storing results from different scenarios. Now the question is, how can we build this array efficiently? And down here we have the constraints. We know that n is smaller or equal to 1000. This means we can think in terms of n squared. So next I will show you 2 solutions. First we will start with this one. We know this is the initial state and we will have 2 pointers, I and j. I is here at index 1 and j is here at index 0. And we are always standing at I. And the question is, what is the number of people which will learn the secret exactly at this point? And for this we can look j, and we know that this person can start sharing the secret here and will forget the secret here. So this is the valid range from this point. And given that I is not within this valid range, we keep 0 here and we continue. Now I is here and j is at 0 again. And we have the same question. What is the number of people which will learn the secret exactly at this day? And for this, we go to j and we check what is the valid range from here. We know that it goes from here to here included. Given that I is within this valid range, we can replace this with 1. Now we update j, and given that this is a 0, we have no secret to share, so we continue. Now we update I and j is at 0 again. We know that the valid range from here goes from here to here, and I is within this valid range, so we can replace this with 1. Now j is here. Given that we have no secret to share, we continue. Now j is here and the valid range from this point goes from here to here included. Given that I is not within this range, we continue. Now I is here and we are trying to answer the same question again. What is the number of people which will learn the secret exactly at this day? We know we start from 0 always regarding j, and the valid range here goes from here to here included. I is not in this range, so we continue. Next we are here, this is 0, so we continue. Next we are here, and we are within the valid range, so we can replace this with 1. Now Shay is here, and we are not standing in the valid range, so we continue. And now I is here, and Shay always starts at 0. Remember, Shay is always smaller than I. And the valid range from this point goes from here to here. We are not within the valid range, so we continue. Now we have a 0, so we continue. Now we have a 1, and we are within the valid range, so we can add this here. Now Shay is here, and we are within the valid range again, so we can add this here. Now we are here, and we are not within the valid range, so we can break this loop here, and we return the sum of the last 4 values. 2 plus 1 plus 1 plus 1 is 5, so we return 5. As I told you before, time complexity for this will be big O of n squared, and space complexity big O of n. So now let's go with the code. First we need to mod the result, and the value is 10 to the power of 9 plus 7. And now we can build our DP array. This is an array with 0 times n, and the first value is a 1. Now for I in range from 1 to n, we are doing exactly the same we did a few minutes ago. And here we can say for Shay in range from 0 to I, if I is within the valid range, meaning it's smaller than Shay plus forget, and it's greater or equal to Shay plus delay, dpi, here we could say plus equal dp Shay, but we need to mod this value, so here we have to say dpi equals dpi plus dp Shay, and this is modulo mod. And now we can get the result like this. We can sum the last forget values. So for I in range n minus forget to n, result is equal to result plus dpi, and this is modulo mod. Finally, we can return result. So now let's submit this and see if it works. As you can see, this works, but it's not very efficient. Basically because here we have 2 nested loops. Now the question is, can we somehow reduce this from 2 nested loops to 1? And the answer is yes. So let's see the second approach. Remember what this value represents. This means that 2 people will learn the secret exactly at this day. And which are these people? Well, here we have 1 person, and here is the other one. And how can we get this right bound? Well, we can take the current index minus delay. This is how we get this right bound. And how can we get this left bound? Well, we can take the current index minus forget. So the key thing here is to realize that this 2 is nothing but the sum of the elements in this window. So now the question is, how can we get the sum of these elements efficiently? Well, we can have a variable, we will call this count, and here we will keep track of the sum for the window at each step. Let's see the full approach. First we are here, and the valid window at this point is out of bounds. It goes from here to here, so we can continue. Next we are here, and the valid window at this point goes from out of bounds to index 0. Now the question is, how can we get the sum of this window? Well, we can take the current count, 0, plus the right bound, 1, minus the left bound minus 1, meaning 0. And this is 1. So the sum for the current window is 1, and we need to replace the current value with this, meaning 1. Now we are here and we need to shift this window. We need to move this one step to the right. So we can take the current count, meaning the sum for this is 1, and we add this value, the value that we are adding to the new window, 0, and we subtract the value that we are removing from the window. In this case, this is out of bounds, so we remove 0. The result for this is 1, so the new window has a sum of 1 also. And just to be clear, this is the new window. This has a sum of 1. And we need to replace the current value with the sum for the current window, meaning 1. Now we are here and we want to shift this window one step to the right, meaning this is the new window. And for this we need to add this value and remove this value. So we take the current sum, meaning this sum, which is 1, we add this 1 and subtract this 1. And this is 1, so this count stays at 1 and the value here is 1. And just to be clear, this is the new window. So now we are here and we are doing the same. We want to shift this one step to the right, meaning we take this and we add this and we subtract this. And this is 2, so the sum for the new window is 2. This is the new window, and we can replace this with the current sum for the current window, which is 2. Finally, we sum the last 4 get values. 2 plus 1 plus 1 plus 1 is 5, so we return 5. And this is how we can go from n squared time complexity to big O of n. So now let's go with the code and hopefully you will get the idea. First we say mod is 10 to the power of 9 plus 7. dp is an array with 0 times n, and dp at 0 is 1. Now the sum for the initial window, we'll call this count, this is 0. And now for I in range from 1 to n, count, the new count will be count plus the right bound of the current window, meaning dp I minus delay, minus the left bound of the current window, dp I minus forget. And this is modulo the required value, and dp at I will be the sum for the current window. After this we can get the result. This is initially 0 for I in range from n minus forget to n. Result is result plus dpi modulo mod. Finally, we can return result. So this is it for the code. Now let's submit this and see if it works. As you can see, this works and it's very efficient. It's much more efficient than the previous solution. Here time and space complexity is big O of n. And this is it. If you found this useful, please drop a like, subscribe, and see you in the next one. Bye bye.